Hello. Now I will study the moment of inertia for solid sphere. Now we are having this solid sphere and the mass of this solid sphere is m and the radius of this solid sphere is r. Okay. So we want to calculate moment of inertia. We don't have that formula right now. So obviously we have to go by cutting the element, and the element should be such that for which we should know the moment of inertia. So whatever element we are going to cut out of this solid sphere, for that element we need to know the moment of inertia. Okay. So for that, what we will do here, this is the center. So this solid sphere can be constructed with hollow spheres. So if I am having number of hollow spheres having different radiuses from 0 to capital R, I will be able to construct the solid sphere. So hollow sphere can be my element. So to create a hollow sphere as my element, what I will do, from the center I will go at a distance small r. After going at a distance small r, I will draw a sphere. Then I will further move by a distance dr, and moving distance dr, I will further cut a spherical element. So between these two spherical surfaces, I am having my hollow sphere. Obviously this dr is very small, so we can assume this to be hollow sphere. So this is my hollow sphere. And the radius of this hollow sphere is small r, and the width of this hollow sphere is dr, and the mass I am defining as dm, obviously. And if you remember, we have a ready-made formula for the moment of inertia of a hollow sphere. You see, this solid sphere, we need to calculate the moment of inertia about the diameter. This is my diameter. And when I cut the element, this diameter is also the diameter for this element, this hollow sphere. And if you remember, we have a formula for moment of inertia of a hollow sphere about its diameter, and that formula is 2 by 3 mr squared. That's the formula. That's the moment of inertia for a hollow sphere about its diameter, where this m is mass of that hollow sphere, and this radius is not the radius of the solid sphere, it's the radius of that hollow sphere. This is mass of hollow sphere, and this r is radius of hollow sphere. This I is moment of inertia of that hollow sphere about the diameter. So you can see, now we need to calculate the moment of inertia for this element, and for that we need two things. One is the mass of this element, and second is radius of this element. Now the radius is already given, this is r, radius of this hollow sphere is r. Now to calculate the mass of this element, we need to first calculate the density. Now to calculate the density, it is given, or we are assuming that mass distribution within this solid sphere is uniform, or we can say volumetric density is uniform. That's what we are assuming. So till it is given otherwise, we'll always assume that density is uniform. So if the density is uniform, the volumetric density rho we can define as total mass upon total volume, which is 4 by 3 pi r cube. This is volumetric density, and obviously here the mass is distributed within the volume. We are defining the volumetric density. Okay. So this is the volumetric density for this solid sphere. Now using the volumetric density, if we want to calculate the mass of this hollow sphere, then the mass of the hollow sphere will be density multiplied with the volume of this hollow sphere. Now this, to calculate the volume, it will be the cross-section area multiplied with the width. Okay. So the cross-section area, if you see, it is 4 pi small r square. 4 pi r square is the formula for spherical sphere, area of the sphere, multiplied with the width, that is dr. So let's put the values. So 3m upon 4 pi r cube, that's the density, multiplied with the 4 pi small r square dr. This will cancel out. So the mass of this element will be 3m upon r cube r square dr. That is my equation 1. So now we have the radius for this element as well as the mass for this element, and we have the formula also. Then using the formula, we can calculate the moment of inertia for this element about the diameter. Then di will be equals to 2 by 3, that's a multiplication factor here, multiplied with the mass, which is 3m upon r cube into r square dr multiplied with small r square. So that value will be equals to 2 by 3. You see this and this, they will cancel out. So this value will be 2m upon r cube multiplied with r to the power 4 dr. That is moment of inertia of my element about the diameter. Now we need to calculate the moment of inertia for the whole body. So moment of inertia for the whole body will be equals to integration of moment of inertia for my element. And this integration should be done in such a manner so that the whole body should be covered. Okay, so let's put the values. So this 2m upon r cube, this is constant, it does not depend upon r, so we'll be taking it out. Integration of r to the power 4 dr. And obviously limit of small r will be from 0 to capital R. If I change the value of small r from 0 to capital R, we will be reconstructing the whole solid sphere. So let's integrate this. So it will be 2m upon r cube. Integration of r to the power 4 will be r to the power 5 divided by 5. 0 to capital R. Let's put the values here. So I will be equals to 2m upon r cube r to the power 5 upon 5 minus 0. So if we put the values, you open it, it will be 2 by 5 capital M r square. So that becomes the moment of inertia for a solid sphere about its diameter. This is MOI for solid sphere about its diameter. Now this formula we can use at any point of time in future. So this formula we have to memorize. This 2 by 5 is the multiplication factor, and mr square it always come actually for spherical bodies or circular bodies. So this becomes the moment of inertia for solid sphere about its diameter. Now one more time, let's go through it. So this time we wanted to calculate the moment of inertia for a solid sphere. So we had to cut the element. So what we did, we went with the hollow spheres, because we can reconstruct the solid sphere using the multiple hollow spheres having the radius from 0 to capital R. So hollow sphere become our element. So to calculate the mass, and mass of that element we have defined as dm, and the radius as r. And the moment of inertia we already have the formula for hollow sphere, that is 2 by 3 mr square. So we wanted to calculate the mass dm, and for that we assume this density is uniform. So we calculated the density, and then from there we calculated the mass of the element. Then using the mass of the element and the radius of the element, we calculated the moment of inertia for the element about the given axis. Then we integrated that, and we got the moment of inertia for the whole solid sphere about its diameter. Okay. Thank you.